Before digging deep into control systems, let us see some basic terminologies which are frequently used in the study. The, the first one we try to understand is the control variable. Control variable is the quantity or condition that is measured or controlled in a control system. Normally, the control variable is the output of the system. Now, this is a quantity or variable that we want to control in a system. Another important quantity is the manipulated variable. The manipulated variable is the quantity or condition which we alter to control the our output or the control variable. So this will be more clear when we see the example. The next term is plants. Plants and systems are an integral part of a control systems. Plants are the main important dynamical part that produces an outcome when we give some input to that. Let us see the definition. A plant may be a piece of equipment or a set of machine parts functioning together to perform a particular operation. For example, a heating furnace, a chemical reactor, or a spacecraft. In our day-to-day life, we can see examples like a tube light or the heater in our room or um, any table lamp, etc. They all get some input from somewhere and they produce an output. Another term closely resembling this plant is the systems. Now let us see an example. Here we consider a plant, a liquid level system, which we also have considered in our previous video. Here we see that there is a control knob or control valve which is controlling the flow of liquid, rate of flow of liquid into the tank, and there is some outlet. But here we are concerned about the height of liquid in this tank, and this control valve is used to control the rate of flow of liquid. So we will try to see the examples which are representing the definitions or the quantities we defined in our previous slide. So this one is our plant because it is taking some input and it is providing some output. So here H, the height of the liquid, is the output. And what is the input to this plant? The rate of flow that is controlled by this knob is the input to the plant. Another thing is the manipulated variable. What is the manipulated variable here? The rate of flow of liquid is the manipulated variable. We manipulate the rate of flow so as to adjust the height of liquid in this tank. Another important thing is the controlled variable. What are we trying to control here? We are trying to control the height of the liquid. So Here in this case, the output or the controlled variable is the height of the liquid in the tank. So this is a simple example where we can see these things. This is a plant. Another example can be a situation where the plant is not so physical. This is a very clear example of a plant, but situations can be that the plant is not so direct, or you can see it like this. It can be a process or a dynamical phenomena. So our next definition is of a system. A system is a more or less like a plant, but plant in when we call phenomena plant, we consider some equipments or machinery like that. But in systems, we don't consider those things. So, a system is a combination of components that act together and perform a certain objective. A system is not limited to physical ones. The concept of system can be applied to abstract, dynamic phenomena. For example, biological systems, economical systems, etc. So the next definition is of an actuating signal. What is an actuating signal? It is the error between, or the difference between, the reference input and the feedback signal. Feedback signal can be a function of the output, or um, the actual output of the plant or the control system. So this is the definition. The signal, that is the difference between reference input and the feedback signal. It is the input to the control unit that causes the output to have the desired value. So an actuating signal acts as an input to the control units, which again produce the controlling signal to actually actuate the plant so that we get a desired output. So here we can see another definition of controller. A controller compares the actual value of plant output with the reference input, determines the deviation, and produces a control signal that will reduce this deviation to zero or to a small value. So here we can see this actuating signal is given to the controller, and controller produces a control signal which again is used to decrease the error to zero or something small, some small value. So it is not possible every time to decrease the error to zero. For some constraints like cost or physical availability, etc., the controller can decide to um, produce a control signal which is best, which gives best performance. So let us see what this means in our example. So this is the control systems. So where is the actuating signal? We get the actuating signal from this comparator. This comparator is giving a difference between the reference signal, the reference input, or the desired level or desired value, which is the objective of the control systems. Here, this the adjusting the height of this liquid in the tank is our desired desired input, and the actual level that is detected by using this output transducer is the feedback signal. So this comparator is comparing this signal, that is the reference input, and the actual output, and giving a signal that is the error signal or the actuating signal. So this is the actuating signal or error signal. This is our controller, which will produce a control signal, which is then given to this actuator. So this is the control signal. See another definition of control action. The manner in which the controller produces the control signal is called the control action. For example, if the controller is producing a control signal which is proportional to the error, then we call that the controller is proportional controller. Or if the controller is producing a control signal which is the integral of the error, then we call it a integral controller. There are various types of control actions which we will study afterwards. So these are some simple examples. There are many different kinds of control actions. Some of them can be linear, some of them can be non-linear. So the next definition is of an actuator. We have seen in our example that the control signal coming from the controller is delivered to a unit named as the actuator. So what the actuator does? The actuator is a power device that produces input to the plant according to the control signals. Now, the control signal is a low power signal. Generally in industries, the control signal is a low power signal. So this cannot be given directly to the plant so that output can be achieved. In that case, the actuator is used. So the actuators are generally, in many cases, can be power amplifiers or power devices that increase the power of the control signal, or then they create a signal, a high power signal that is given to the plant, and they the plant gives the desired output. For example, um, as an actuator, electric motors, hydraulic motors, pneumatic motors or valves are um, some of the equipments those are used as an actuator in an industry. So the units that occur between the comparator unit and the output are termed as forward elements or forward dynamics. This is the definition: the unit that reacts to an actuating signal to produce a desired output is known as forward element. The unit that provides a means for feedbacking the output quantity or function of output in order to compare it with the reference input is known as the feedback element. So let's see these things in our example. So here the units that are present between the comparator unit and the output, that is these things, these form the feed forward unit. These are all known as feed forward elements. The other thing is the feedback element. Feedback element are between the output and the reference, sorry, the comparator unit. This one is the comparator unit, and this line is starting from this output and going towards this comparator unit. What is the difference between two is that the direction of the signal. For forward element is from this direction to this direction, and for the feedback element we can see the direction is from here to this. So the direction of forward elements is reverse to the direction of the feedback elements.